probably why I skimped on it. All right, find the area of the region enclosed by y equals x cubed minus 4x and y equals x squared minus 4. Well, we have a bit of a loop here because look at this graph, these two graphs. Y equals x cubed minus 4x. What does it look like? Something like this. Okay? Y equals x squared minus 4. Well, let me go ahead and put it on here with mine. Yeah, let me do this. Let me draw it a little bit wider perspective here. Here's 1 and 2. Here's 1 and 2. Okay. There's the x cubed one. And x squared minus 4, well, it comes down a little lower than that, obviously. Kind of goes through the same intercepts. But do you see the ordeal? We've got two parts enclosed here. I've got the part here on the left, a little bigger part. Then I also have a smaller part, but it's not insignificant. It does have area there. So I've got to take that in consideration. Now, these two do look like they are the 2's, the negative 2 and positive 2. We can verify that. The intersection points here are the graphs. Oh, and then this one looks like it's 1. But just to be safe, how can we find those? Set the 2 equal, right? X cubed minus 4x equals x squared minus 4. Make one side 0. X cubed, subtract the x squared, and add the 4 and arrange them like this. A little bit of grouping. We haven't done that one. One way to do that one. Factor off an x squared off these first two. That gives us an x minus 1. Factor off minus 4 off the next two. That gives me an x minus 1. So we have a common factor of x minus 1. So I factor an x minus 1 off there. That leaves me x squared minus 4, which just so happens to factor as x minus 2, x plus 2, which, yeah, those intersection points will be 1 and 2 and negative 2. Okay, so that's what they are. Negative 2, 1, and 2. Those are the intersection points. Well, to get this total area, though, I can't just say negative 2 to positive 2. Why not? Why can't I just do an integral from negative 2 to positive 2?
The area from 0 to 2 under the curve is not part of the intersection.
Well, the thing is, if I do, which one you want to do the top? If we do negative 2 to positive 2, which one are you going to do the top? Because part of it has the top interval is the x cubed, and part of it's the top interval, the top graph is the x squared graph. So what we have to do is, like our absolute value thing, break it up into 2. Let's go negative 2 to 1, because on that part, what have I got? I've got the x cubed graphs on top and the x squared graphs on the bottom. So that would be x cubed minus 4x minus x squared minus 4. And then they reverse from 1 to 2. They reverse. The x squared graph's on top, isn't it? This is the x squared graph right here. So the x squared graph's on top from 1 to 2. The x cubed graph's on the bottom. So that's the x squared minus the x cubed. That range. With me on that? Well, here's what we'll notice here. This will be x cubed minus 4x minus x squared plus 4. There's no like terms, unfortunately. This one will be 1 to 2. It'll be x squared minus 4 minus x cubed plus 4x. You notice something about those. Well, they're opposite signs all the way across there. All right. So a little bit of work we got it. 1/4 x to the 4th minus, that'd be 4 halves, it'll be 2x squared minus 1/3 x cubed plus 4x from negative 2 to 1. And then this will be 1/3 x cubed minus 4x minus 1/4 x to the 4th plus 2x squared from 1 to 2. Okay, so the first one's a 1 on that one, so we got 1/4 minus 2 minus 1/3 plus 4, don't we? Then with minus 2, that'd be a positive 16. 1/4 times positive 16. Minus 2 times positive 4 would be minus 8. Minus 1/3 times minus 8. Minus 8. That's what I get for the first bit of it. Then over here, second part, I have 2, so that'd be 8/3 there. Minus 8. 1/4 of 16, so that'd be minus 4. 2 times 4 is 8. That works out nicely. And then the 1s would be 1/3 minus 4. Minus the 4th plus 2. Got them on there. Okay. I do see some 8s canceling. This will be a positive there. 4 minus 4, there's a 4 minus 4, yeah. Oh, I could have done it with that one too. That's a minus 8 and a minus 8. There's a minus 8/3. Is there a positive 8/3? Yep, there is. Because that'll be a minus 8/3. Negative 4, yeah, okay, so that one will go out. There's a 1/4, but that's going to be a positive 1/4 in it. Okay, so all that taken out, let's see what we got. 1/4 minus 2 minus 1/3. That'll be a plus 8. Change the signs. Plus 8. I got 16. And here, what's left? Minus 1/3 plus 1/4 minus 2. I think. What did I say? Minus 1/3. I put plus 1/3. Plus 1/4 minus 2. I think I got it. 1/4 minus 2 minus 1/3. Plus 16. Change those signs. Okay. 11.833, which is 7/1/6. Anyway, okay. Questions or concern? Huh? That was a long one, yes. Lots of numbers. Yeah. Okay. Any other problems or concerns? All right, here's another one then. find the area enclosed by y equals x, y equals 3x plus 1, and y equals negative 2x plus 3. We got three curves. Y equals x. Well, that's our 45-degree line, if you will, right? You got 1, 1, 2, 2, 3, 3, so forth. Okay, 3x plus 1 looks like this. We got 1, and then rise over run. 1, 2, 3, rise, run 1. Try that again. And then we have minus 2x plus 3. So y-intercept here is 3, and it's a down 2, run 1. So we've got ourselves a little triangle there, don't we? Right in here. Okay. All right. So yeah, if I basically what I've got here, maybe I should blow this rectangular part here up a little bit. Yeah. Probably can guess our intersection points, but yeah, we've got basically three intersection points. I can't remember which one this was. This was 3x plus 1, wasn't it? This was y equals x, 2x plus 3. But yes, I do need to know those points of intersect there. This intersection point would be the one between the 3x plus 1 line and the y equals x line. So that one's going to be when 3x plus 1 equals x. Subtract x and minus 1. It's negative a half, isn't it? So my graph's off just a hair. Maybe this is why, because my slant on that one wasn't quite so accurate. But yeah, that point's at negative a half. This one, it looks like, that's between the negative 2x plus 3 line and the 3x plus 1 line, right? So that'd be negative 2x plus 3 equals 3x plus 1. So yeah, these aren't nice whole numbers, are they? Let me add the 2x and subtract the 1. Right? So that would be 2 equals 5x. That's 2/5. Who picked these numbers? Okay. Point being, it's not always just nice whole numbers. All right, and then this one that's the x and the minus 2x plus 3. So that would be add the 2x. Oh, that one is nice. Finally. Thankfully, one of them's nice. X equals 1. So I've got intersection points at a negative a half, positive 2/5, and a 1. But let me expand that out just a little bit. Okay, so I got y equals x here. Negative 2x plus 3, that is, so that one's here. That's the one that intersects nicely at 1. And then the 3x plus 1, I think one more, don't I, is here. Still didn't. Oh, that point's just too close. Okay. So we got negative a half, positive 1, and then this one is 2/5. What are we going to have to do to get the area between it, though? I have to do two integrals. Because from the 2/5 to negative 1/2, what have I got? Well, on top, I've got the y equals 3x plus 1, but what's on bottom? Y equals x. From 2/5 to 1, what have I got? Y equals negative 2x plus 3 is on top, and on bottom is y equals x.
That one, why are you calling the y? They both go up. So why isn't the y equals x on top?
Y equals x on top. Right here, it's on bottom both cases, isn't it? This is on top, that's on bottom.
Okay, so we're not talking about the area between the x-axis and that.
Talking about the area enclosed by those three curves. So it's this triangle right here. So yeah, it's two integrals. It's the integral from negative a half to positive 2/5. And there, what's on top? You tell me. 3x plus 1's on top, and x is on bottom, okay? So it'll be 3x plus 1 minus the x dx. Then the other part, has, this is on top, which is negative 2x plus 3. The x is on the bottom again. Right? And that goes from 2/5 to 1, or 0.4 to 1. Well, that's the hard part. Easy part's now integrating, I guess. Well, it'd be, that would be what, 2x plus 1 all told when we combine them. And this would be minus 3x plus 3. Combine those there, so it'd be, what, x squared plus x from negative a half to 2/5. And this would be negative 3/2 x squared plus 3x from 2/5 to 1. Did I do that right? So I'm getting 2/5 squared, which would be 4/25, plus 2/5, minus negative 1/4 squared, be positive 1/4, minus a half. Over here, plug in the 1, you have negative 3/2 plus 3, minus, plug in 2/5, you have negative 3/5 times 4/25. And then you'll have inside there plus 6/5. Something like that. All right, so I'm not going to try to cancel those. 4/25 plus 2/5 minus 1/4 plus a half. Right? 81/100. That's what I get for that. Not talking much area there. And then over there we'll have minus 3/2, sorry, plus 3. Minus minus will be plus 12/50. Which reduces, of course, but, and then minus 6/5. 0.54, 54/100. Which is 135/100. 1.35. (27/20).